You know, right now, as we speak, there's an invisible storm hurtling towards Earth at millions of miles per hour. It all started with this massive eruption on the sun, and it's about to make an impact. So what exactly is heading our way, and what does it mean for us down here on the ground? Let's break it all down.
So the official word comes from NOAA's Space Weather Prediction Center. They've put out a G2 geomagnetic storm watch. Now that G scale goes from G1 all the way up to G5, kind of like how we categorize hurricanes. A G2 is moderate, so not the most extreme thing ever, but it's definitely a significant jolt to Earth's magnetic field.
And that's the real question, isn't it? An alert is one thing, but how does a storm that's happening 93 million miles away actually affect our daily lives? Well, that's exactly what we're going to get into.
Okay, first up, let's get on the same page about what we're even talking about. Because when scientists issue a geomagnetic storm watch, they're not just using some catchy phrase. They're describing a very specific and pretty powerful event. A geomagnetic storm is basically a huge disturbance of Earth's protective magnetic bubble, what scientists call our magnetosphere. It happens when a blast of energy and particles from the sun just slams into that shield, transferring an incredible amount of energy into our little corner of space. Honestly, you can think of it like a space hurricane making landfall.
So, where did this particular space hurricane come from? Well, to understand that, we have to rewind the clock a couple of days and take a trip 93 million miles back to the sun.
This whole thing kicked off on the surface of the sun, at a pretty volatile sunspot region that's officially labeled AR 4299. It was right there that a really powerful solar flare erupted, just this giant, brilliant explosion in the sun's atmosphere.
And when I say powerful, I really mean it. Scientists classified this flare as an X1.9. So what does that number actually tell us?
That X is the most important part. See, solar flares are categorized, and X-class flares? They're the most powerful category there is. We're talking the major leagues of solar eruptions. The 1.9 just tells us how strong it was within that top tier. So the takeaway here is simple. This was a big one.
And we know exactly when it happened thanks to NASA's Solar Dynamics Observatory, which is basically watching the sun 24/7. It captured the whole thing, seeing the flare peak at 9:49 p.m. Eastern Time on November 30th. But here's where it gets really interesting. That brilliant flash of light, the flare, that's not actually what's heading for Earth. This is a super common point of confusion, but the difference is absolutely crucial for understanding what happens next.
As NASA explains it, while they often happen at the same time, a solar flare and something called a coronal mass ejection, or CME, are two totally different things.
This slide lays it out perfectly. The flare is the brilliant flash of light. Think of it as the muzzle flash from a cannon. It gets here in minutes, but the CME, is the actual cannonball. It's a massive cloud of solar plasma and magnetic fields that gets hurled into space, and that is what's currently hurtling towards us. Okay, so we've got this massive cloud of solar material, this cosmic cannonball, traveling through space. The next huge question for the forecasters was pretty simple. Is it going to hit us? Well, according to NOAA's analysis, the eruption wasn't pointed directly at Earth, which is good news. Most of the material is actually traveling east of us. However, they do predict that the edge of this massive cloud will still hit us, which results in what they call a glancing blow.
And this timeline just shows you that delay perfectly. The eruption happens on November 30th. Forecasters spot the CME and issue the alert a day later, on December 1st. And the impact? That's not even expected until December 3rd or 4th. It takes a few days for that cannonball to travel all the way across the solar system. You know, it's really important to remember that just like weather here on Earth, space weather forecasting isn't perfect. The forecasters are pretty clear there's some uncertainty. The storm could get here a little earlier or later, and its intensity could change depending on exactly how that cloud interacts with Earth's magnetic field. Which brings us right back to our original question. What does this all mean for us down here on the ground? Well, the impacts really fall into two main categories: some risks to our technology and also a pretty spectacular gift from nature. So, on the one hand, a moderate storm like this can pose some risks to our tech. It can create weaknesses in power grids, it can mess with high-frequency radio, and even interfere with the GPS signals we all rely on every day. But on the flip side, all that energy also creates something absolutely beautiful. It supercharges the aurora. And this is the truly beautiful part of the story. The energy from the storm excites particles in our upper atmosphere, creating that incredible light show we all know as the Northern Lights. And for this event, the aurora could be visible much farther south than usual,
potentially across northern states all the way from New York over to Idaho. So while we wait for this glancing blow to arrive, the source of all this activity, that giant sunspot, AR4299, is now rotating to face Earth directly. It's already proven it can produce major flares, and the question that all the forecasters are now asking is, what will it do next?